Here's the electromagnetic spectrum. I'm going to look at how we use these electromagnetic waves, starting from the radio waves, which has the longest wavelength, all the way to gamma rays, which has got the shortest wavelength. Okay, firstly, radio waves. Now, the wavelength of radio waves can be as large as the size of a hill, but it can be as small as the palm of your hand. It's used in broadcasting and communications, which basically means TV and radio. Okay, next we have microwaves. Now they're roughly the size of your thumb and they're used in cooking. So for example, a microwave oven like this one. They're also used in satellite communication. So we can send a signal to a satellite as a microwave and then back down. Now because some microwaves cause heating, you need to be careful because it can cause internal heating of body tissue. So this is not all microwaves, just a tiny range which you need to be aware of. After microwaves, we have infrared. Infrared is mainly responsible for transferring heat. So electrical heaters, for example, they emit infrared. Now there's red glow, that's actually visible light. The infrared is the heat that's transferred. Okay, we can't actually see the infrared waves. It's also used in cooking food. So for example, when you put food under a grill, the infrared waves heat up the food. And it's also used in infrared cameras. So infrared cameras look at how hot things are, how much infrared radiation they're emitting. So in this diagram here, you can see the windows are quite hot, they're glowing because they're emitting a lot of infrared, while the roof is not emitting much infrared. Now, because infrared transfers heat, you need to be careful because it can cause skin burns if you expose yourself to too much infrared waves. Okay, next we've got visible light. That's the light that we can see, which is why we call it visible. Okay, it's obviously used for seeing. So when we see an apple, that's because light is reflecting off that apple and it's going into our eyes. It's used in photography. It's used in optical fiber communication. So your internet right now is probably optical fiber. That means the information is being transferred as light through the optical fiber. Okay, next, we have ultraviolet, which is used in energy efficient lamps. So for example, this one. Now the glow that we're looking at here is actually visible light, but however, inside the energy efficient lamp is actually using UV light, which it turns into visible light. Next is also tanning. So ultraviolet causes tanning. So when you're in the sun is emitting visible light, but it's also emitting a lot of UV ultraviolet rays, and that's what causes tanning. Now there's also artificial tanning, which you can get from a tanning bed like this, because it emits ultraviolet and that can cause your skin to tan. Okay, now there is a bit of danger with ultraviolet is if you get expose yourself to too much ultraviolet radiation, it can cause skin cancer or could cause skin cancer, not necessarily will. And also it can cause premature aging of the skin. Basically what that means is that your skin looks older than what it should be because you've been exposed to too much ultraviolet light. After this even shorter wavelength, we've got X-rays. Now, X-rays are obviously used for medical imaging. So CT scans and X-rays like this. And that's because they can go through soft tissue, but they get absorbed by bone. So they create a shadow which we can see to find fractures. Also, we use it to check for cracks in machines, not just bones. So if we fire X-rays at a machine which might have a crack in it, it will go through the crack, but the rest of the X-rays might be absorbed by the machine. So we can identify where the crack is. Now, X-rays is very high energy, so it's what we call ionizing radiation, which means that it could cause mutations in the genes of people when they're exposed to it, and it could lead to cancer. So there's a risk of cancer with X-rays. Okay, finally, the shortest wavelength, we've got gamma rays. Gamma rays are used to sterilize food and medical equipment. So let me give you an example. So in this picture, we've got a surgeon who's putting his surgical equipment inside this oven-like thing, and that's going to fire X-rays at the scalpel and the scissors, and is going to kill any bacteria or viruses on it. Okay, so it's going to sterilize it. Okay, then we've got use it as medical tracers. So sometimes we inject gamma emitting isotopes into people, and as it goes through the people we can track the isotope as it emits gamma rays, because the gamma rays will leave the person and can be detected outside. And finally, we use it for radiotherapy. So we fire gamma rays at certain parts of the body if we want to kill, for example, a tumor. So if we concentrate all the gamma rays, it will kill all those cells because it's quite high energy. Now, there's a lot of risk with this, same as with X-rays, because sometimes when healthy tissue gets exposed to gamma radiation, it can be mutated, the genes and the DNA can get damaged. So this could also risk cause a risk of cancer. And it could just kill your cells well, but it can also lead to cancer.